see how the colon operator works, let's start with a simple example. X equals 1 colon 3 colon 7. I hit return, and I get 147. X is a vector. Here's what the meaning of this colon operator is. And notice we've got 2 colons in the so-called colon operator. It means start at 1, increase by steps of 3, and stop before you go over 7. Go no higher than 7. So we add 3 plus 1, we get 4. We add 3 to that, we get 7. If we added 3 to that, well, it would be over 7. This concept of incrementing and going no higher than a limit sometimes is confusing. Let's look at 1, 3, 8. We start with 1, we add 3, and we continue, but we go no higher than 8. Well, we got the same result here. Because if we added 3 to 7, we would be higher than 8. So it stops at 7. Let's try this one. Still no joy. Let's try this one. We want to get another number. Nothing's happening because if we added 3 to 7, we'd be higher than 9.9. So finally, let's do this. 1, 3, 10. This starts at 1. We add 3 and get 4. We add 3 and get 7. We add 3 and get 10. MATLAB checks. If you add 3 to 10, would you be higher than 10? Well, of course, so it stops. There's a special shorthand if you want to go up by 1 instead of, say, 3. Let's call this variable ints. We'll set it 1 to 100. This is the same as going up by 1. Just 1 colon is needed. And, well, we get 100 numbers here. Let's look at the size of this variable. It's a 1 by 100 vector, as you can probably see. So we call this the colon operator. Well, what's the definition of an operator? Pretty simple. You've seen a function. An operator is a function that's invoked by a symbol. A function is an operation that's invoked by the name. So the name of this special kind of function is a single symbol, or 2 symbols, as in the case of 2 colons here. Plus and minus are probably the most familiar examples. Let's look at 1 plus 2. Of course, we get 3. There's another function that does the same thing in MATLAB, plus 1, 2. The first one is an operator. The second one is a function. They're both called plus. One's a word, one's a symbol. There's a colon function that does the same thing. As this. So the first one is the name colon. The second one is the colon symbol. As you learned in lesson 1, we call the inputs to a function call arguments. For an operator, we call them operands. For a function, the arguments are surrounded by parentheses and separated by commas. For operators, the inputs are separated by the operators themselves. For example, 1 plus 2. The plus separates the 2 operands, 1 and 2. If you had multiplication, 10 times 20, the operands are 10 and 20. They're separated by the operator asterisk. And of course, here we have 1 and 7 separated by the colon. And you can even have 2 symbols in the colon operator, so we can separate 3 operands with the 2 colons. The colon operator is very useful for generating huge vectors of equally spaced numbers. Suppose we wanted all the odd numbers smaller than 1,000, starting with 1. We might set z equal to 1 colon 2 colon 1,000. Before I hit return, fill the screen, notice that we're going to start at 1, then we're going to add 2, that'll give us 3. Then we add 2 to that, that'll give us 5, 1, 3, 5, 7, and so on, all the way up to, but as you know, since 1,000 is not reachable as an odd number, it doesn't quite include 1,000. So we go to 999. If we added 2 to 999, we get 1,001, which would be greater than 1,000, and MATLAB won't do that. Let's look at the size of z. It's 1 by 500. There are 500 odd numbers from 1 to 999. Suppose we wanted the even numbers that are smaller than or equal to 500. Let's call those evens, and we'll set them to 2, 500. We start with 2. We keep adding 2 till we get to 500. 2, 4, 6, 8. And there are those numbers. What's the size of that vector? Well, it's 1 by 250. You can have decreasing sequences too. Let's start with 7, go down by 3, and end up at 1. 7, 4, 1. So we start with 7. We subtract 3, that gives us 4. We subtract 3 again, that gives us 1. If we subtracted 3 again, we would be less than 1. So the rule now is, instead of go no higher, it's go no lower. So we go no lower than 1. Let's look at one we'll call down by 10. It's equal to 100 colon minus 10 colon minus 100. So here we start at 100. We decrease by 10. We add minus 10, in other words, until we get to, and don't go below, minus 100. And there's the numbers. Size of this is 1 by 21. Again, it's a vector. You always get row vectors with the colon operator. You never get a column vector. If you want a column vector, you have to change it into a column vector, and we'll show you how to do that later. I want to show you a strange thing. X equals 7 colon 3 colon 1. So innocently, I type 7 colon 3 colon 1, meaning I want to start with 7. I want to change by 3 until I get down to 1. I hit return, and I get this strange thing. X is the empty matrix, 1 by 0. Well, what's the difference? Last time I typed 7. Well, here I had a minus 3. Here I have a plus 3. And there's the problem. I want all the numbers that start at 7, get bigger by 3, and end up at 1. Well, there is no such number or numbers. So it gives us the empty matrix. Let's see what the size of X is. 1 by 0, just as it said. There are other sizes of empty matrices in MATLAB. And by empty matrix, we don't mean a matrix with zeros in it. We mean a matrix with nothing in it. Here's how to get that other kind. You just type nothing. So we typed X, a left bracket, type nothing, and then type the right bracket. And it shows that it's an empty matrix. It shows it a little differently here. Let's look at the size of X. This time X is 0 by 0. Before it had one row with nothing on it. You always get a row matrix, as I mentioned, with the colon operator. And sure enough, we got a row matrix here with nothing in it. One row, no elements. Here, we didn't indicate whether we wanted one row of nothing or one column of nothing, so it gives us no rows, no elements.